it's a really good, going from the CAD into the subtractive. Now we're going to go into the additive, the other side. And this is just another way that CAMS is expanding their capabilities. I just want to encourage everybody, the way we do business has changed. And if you're seeing bottlenecks in your processes or your manufacturing, anything like that, give us a call, because we work with a lot of different people, and we have a lot of really smart people who work with us. Not me, but the other guys you see on the screen that's doing all the main talking. That we could maybe stop out and see, or maybe we could do a Zoom meeting or something, depending on what your situation is, and help you through some different things. So we want to partner with you and be your partner. And Joe's going to explain to you now the CAMS 3D printing and how we can partner with you in that way too. So Joe, I'll go ahead and turn it over to you.
Thanks, Don. My name is Joe Lewers. I am the 3D printer specialist here at CAMS. And I'm just going to do a quick overview of the printers and services that we offer. I know it's been a bit of a long presentation, so I'll try and keep it on the briefer side compared to everybody else. So we offer Markforged printers and BigRep printers. So we're going to start with Markforged. And they have a couple different options for printers. They have the desktop series and the industrial series. Each of these are very similar. The main differences between the two of them is the desktop series is overall smaller, as you can see from the picture, but the build volume on the industrial series is bigger than the desktop series as well. These printers have a smaller range of materials available to them compared to like your standard hobby level or other printers. But their main material is onyx, which is a nylon-based thermoplastic with shredded carbon fiber reinforcement mixed inside of it. They also offer nylon white, which is just their nylon without the carbon fiber inside of it. And then Onyx FR, which is their onyx material with flame retardant. So this here is their onyx material, which you can see is just black. There's nothing special about it color-wise or anything like that. The nylon white is obviously white, as the name says. Now, the unique thing about these printers is they do fiber reinforcement. So with, it works alongside the onyx material, but it will lay down strands of fibers. So they offer a couple different fibers for reinforcement. They have fiberglass, high strength, high temp fiberglass, Kevlar, and carbon fiber. And with these reinforcements, it really brings out the strength and the uniqueness of all these parts. With the carbon fiber reinforcement, these parts are similar in strength to aluminum with their strength to weight ratio. Kevlar is very good for things that repeated loading, you don't want to break, but maybe need to yield a little bit. And fiberglass is, similar to the carbon fiber, just on a lesser scale because it's not carbon fiber. So I'm going to show a quick video on the part strength because it's pretty impressive here. So there's no sound or anything like that. So the goal of this chain link, so this right here is a chain link, and the goal for Markforged when they printed this was to lift a dump truck. And you could see it broke at 22,000 pounds, which is just barely enough, they said, to pick up a cement truck. So that really shows how strong those parts can be. And that's just plastic, with carbon fiber reinforcement. So next, we are going to their metal 3D printer system called the Metal X. And it's actually a whole range of items. So you actually have your 3D printer here. There's a wash and there's a sinter. So it is filament based. And they have a little video here that I'm going to show that explains it pretty well. Let me know if you guys can hear everything.
I'm here to talk today about the Markforged Metal X process. It's a simple, safe, and cost-effective method to go from design to functional metal part. There are 3 steps in this process: printing, washing, and then sintering. First, let's start with CAD. You design your part, then export to STL and upload into Eiger. Eiger is a cloud-based slicing and print management system that comes with every Markforged product. This automatically configures your part based on the material and printer you've selected. When your part slices for metal 3D printing, it gets scaled up to account for shrink and deformation in the downstream processes. It then slices your part into discrete layers, identifies overhang features, and builds supports and a raft underneath your part. As we go through printing, washing, and sintering, Eiger will monitor the part's progress along the way. Let's start this print and go to the Metal X. Before starting a print, the machine automatically maps and levels the bed to ensure the first layer goes down well. Your print is built of two materials stored in this heated chamber above, one of ceramic release material and one of the metal to be printed. This filament material is metal powder safely suspended within a two-part plastic binder. It gets heated and extruded onto the build plate where the part is created layer by layer. The release material gets extruded as an interface between the part and its supports, so that once your part comes out of the furnace, it's easy to remove. Unlike other metal 3D printing systems, this process does not require loose metal powder, resulting in a safer and more cost-efficient workflow. 17.4 stainless steel is loaded now. However, with a quick changeover, the system is capable of printing in stainless steels, tool steels, coppers, Inconel, along with several other materials currently in development. Once your part is finished printing, you'll get a notification. At this point, you can go to the printer, remove the part from the build tray, and clear the bed. Now we have what's called a green part. It doesn't really look or feel like metal. However, a large part of it is comprised of metal powder. Next step will be putting it into wash 1 for the debind process. The wash 1 removes the first stage of the binding material. A green part is taken from the printer and placed into the wash basket, which is then lowered into the solvent. Wash times will vary, ranging from a few hours to a few days, depending on the thickest region of your part. After that, it's now called a brown part and is ready for sintering. Let's go over to the furnaces. This is Sinter 2, a furnace designed for mid-volume production runs and larger printed parts. Sintering transforms a print from a lightly bound collection of metal powder to a fully finished metal part. First, the temperature ramps slowly to burn away the trace amounts of remaining binding material. Then, temperature ramps closer to the melting point of the material, allowing metal particles to start to fuse together to create a strong metal part. Markforged sintering furnaces use a carbon-free retort to ensure part quality and alloy composition standards are met for our finished pieces. Each run takes about a day and can be monitored remotely using the Eiger software. Once a run is complete, the setter tray full of finished metal pieces can be removed from the furnace. Once removed from the raft, these parts are ready for use. In the furnace, the layer of printed release material between supports and the raft and your printed part remains powderized. This allows the structure to be tacked to the raft to better control shrink and accuracy throughout the process, but also an easy release after sintering. At this stage, your part is fully sintered and ready to be used. It can be post-machined, polished, or otherwise processed as necessary for the final application, but in many uses, the accuracy and strength are good enough as is. It's ready for install. Check out markforged.com for more information about our simple, safe, and cost-effective method of metal additive manufacturing. Hi everyone, I'm here to talk today.
Don't play again. So as you can see, the metal system is fairly unique. You know, there's a lot of other metal printing technologies out there, DMLS. You know, this is a unique way of doing it. It eliminates most of the hazards of traditional metal 3D printing. You're not dealing with powder state parts. You don't have to, you know, get decked out in a hazmat suit or anything like that. And you don't need a lot of training. Now, you know, you do need training to run the machine, but it's nothing of the sort of normal metal 3D printing. So some materials for, they went over it in the video, but right now they currently offer stainless steel, three tool steels, H13, A2, D2. They also offer Inconel and copper. Currently in development, they are working on titanium. Not sure when that'll be out, but it'll be interesting when it comes out. So they showed briefly in the video the Eiger software. What it is it's a cloud-based slicing system. I don't know if anybody's used 3D printers before, but there's slicers that you would have on your computer to generate the tool path for the printer. This is cloud-based. And what that allows you to do is it allows you to keep all your parts together on the cloud. and you can access them anywhere, start a print from anywhere, and it'll save all your builds, and it generally just makes life easier. It communicates with the machines very easily. So I am going to just run a quick demo showing Eiger, because it's a lot easier just to show it than it is to talk about it because of how easy it is to use. So Eiger is, like I said, slicing. It's a slicing software. I've already imported this brake lever here, and this is the main screen when you're ready to slice something. On the left, it shows print time, material cost, part mass, and how much volume of plastic and fiber that you're using. So on the right, you can change a couple settings. Nothing too spectacular, other than the reinforcement of the part. So right now I have it set to Kevlar because it's easier to see when we go in the internal view. You can also change your material here, but we are running this on a desktop series, so we cannot print in any of these metals here or Onyx FR. On the settings tab, you can change your layer height, supports. You have a couple different options. We have turbo infill and turbo support, so this allows you to print quicker, potentially sacrificing some surface quality, and especially with the turbo supports, that can be tougher to remove. Infill, there's a couple different options here, different kinds of infill, and they actually only give you a range that you can change the infill setting to. So I can go from 55 to 30 to 28 when I'm in triangular. And the same with roof and walls. They only allow you to change so much, and that's due to the fact that they have these printers dialed in perfectly, and they know the ranges that these printers will print successfully, and it just makes the experience a whole lot easier because you can't generally mess it up. Real quick, I want to show you guys the internal view, showing the Kevlar that is actually reinforcing the part on the inside. It takes a little bit to sometimes run the toolpath, and that's because it's cloud-based. So if your internet is slow, you might have some issues. You can also do local slicing. Nothing too difficult about it. But if we run to the internal view here, this is where you could do more fiber editing. But if we go 2D, you can see here, when I scroll through the layers, the yellow is the Kevlar reinforcing the part. This will, if you use carbon fiber, this will greatly increase the strength. This part, you can bend this for days if you wanted to and try and break it. You're just not going to be able to. So that's just a quick demo of Eiger. And then here is where all the parts are saved. So you're going to see all the parts that we have ever printed here at CAMS. They save them, and if you ever needed to go back, you have all your print settings saved, and it makes it really easy to use the system. So let me go back to my PowerPoint. So this is the brake lever completed. The surface finish with this Onyx material and these printers I have yet to see a printer that does it as well so regularly. And I've been using printers for quite a while and use them at home too. This is what I strive to make my parts look like. So how does this benefit my company? If I were looking into to getting a 3D printer, what would I look for? Well, if you have supply chain issues, and I'm sure plenty of people do right now with COVID, this can actually really help that. If you have potentially one-off parts that need to be outsourced, this can really take the place of many of those parts, especially if they're weird organic shapes that are very difficult to machine. 3D printing that's where 3D printing shines over subtractive manufacturing. You can also do rapid prototypes, user-end parts potentially, and this will decrease the time it takes for your product to get to the market, which, is very good. So on top of that, we have ease of use, which I just showcased. Basically, I showed you all of Eiger, and it's just extremely easy to walk through, learn, and get a print started. Reliability. So I have actually an example that I've had. One of the bearings on this printer went out after some, I don't know, 10 months of use, and it actually just kept printing fine. And I had a 30-hour print that I was more than halfway through. I let it run, and you wouldn't have been able to tell that anything happened to the printer at all. So reliability is key, and these printers rarely break down. So now we're just going to quickly touch on BigRep. BigRep is a large-scale additive manufacturing. They offer printers that are close to a meter cubed in build volume, and they have a couple of them. I'm not going to touch too much on them because it takes some time to get through them. But their build quality is one of their main selling points. They use Bosch Rexroth CNC control systems, so you have high accuracy and high repeatability with your motion system, which also allows for higher speed prints because the quality is so high. They have open source filament, meaning you can use any filament you can buy on their printers. They also sell their own filament, and they develop their printer settings for that specific filament. So you can choose to get other material, but you'll have to dial in all your settings that way. But if you buy their material, they'll have printer profiles, making it a lot easier to start a print. Their main selling point is their MXT extruder. So the MXT extruder is a revolutionary kind of extruder. It has a reservoir where it pre-melts the filament. And this allows you to speed up tremendously because especially on these printers, you're limited by how much material you can push through the nozzle. Well, with these printers, they store already melted material in a reservoir, which allows you to spit it out as quickly as you possibly can. This can decrease print time tremendously because of that. They say you can see anywhere from 2 to 5 times faster prints compared to other standard printers on the market. So some quick use cases. Fixturing. Fixturing is a pretty big one. So like this is a weld fixturing, pretty good example. It shows you're trying to weld that corner together. Not super easy to do with any printer really, especially the Markforged and BigReps. You can get a jig up and running, and you can quickly and reliably weld up this fixture. Large-scale prototyping. This one is strictly a BigRep application, but they made a fully 3D printed motorbike. And this here is a pretty good example of how big their prints are. They printed this whole body in one piece. This one touches back on the supply chain. This is a socket for a medical screw implant. And during COVID, the company was having supply chain issues, and they were able to print this part because apparently they break pretty quickly right here, these little knobs here. And so they were able to print these parts when they need them, and rather than wait for their supplier. And lastly, I'm going to run another quick video case study for our customer RPG Industries. They use the Metal X and the composite printers in conjunction.
My name is Bob Ginsberg, and I'm the president and founder of RPG Industries. We are a job shop specializing in precision manufactured components. At RPG, we've always tried to be on the leading edge of technology. It started with wire EDM, and we added our first abrasive water jet machine in the late 1990s. We were one of the first shops in the area to have abrasive water jet. We've always tried to lead the market.
Not sure why that happened.
Lag behind. And we felt that additive was our next step. When we were introduced to the Metal X, we were blown away. We saw the possibilities. We can cut delivery times down considerably. We were able to print overnight, lights out, without any human intervention other than getting the printer started. We greatly save time, and time is money. We have a customer, D&D Automobile Restoration. They had a part from a classic car that they're restoring that is no longer available.
The part they're making for us now is for a Solex carburetor. It's a part we cannot find anywhere in the world at the present time.
This is a one-of-a-kind part, the perfect use for the Metal X.
We were desperate and they approached us about this new technology that they had just acquired.
They were excited. They were getting very frustrated. We took the part from them, we scanned it, we created a model.
RPG printed a part in Onyx for us as a trial run. We fit that to the carburetor and it fits perfectly.
They were able to tap the holes in the Onyx, test fit it, make sure that everything would work, and then we went ahead and committed to printing it on the Metal X. If you were to try to machine this part from scratch, it would be cost prohibitive.
It enables us to put this car back the way it was originally delivered, which we were unable to do at this point because we didn't have that part. Now we're going to be able to create that part and make this car whole again. So it's wonderful.
Composite and metal printing are really going to be the future in our industry, and we want to be the early adopters and the experts in that area before it becomes mainstream.
That was pretty cool.
Yeah, so they actually, so their owner got metal certified to install metal printers. He actually trained me on the metal system. Yeah, they do some cool stuff over there. So that is the end of my presentation here. If you have any questions or interest in knowing more about any of our systems, you can contact me or Diana. Diana's our. Good.
I got just a couple of questions already here, Joe, if you don't mind taking them.
Okay, sure.
First question is, how is the accuracy and repeatability with the Markforged?
So for their composite printers, the accuracy is 125 microns, repeatable across their build volume. So I think that's 5 thousandths. The metal system, they call it a near net finish because it's really difficult to say what it is. It's very part dependent. But as for accuracy, if you really need high accuracy, you're better off machining the area that you printed just for ease of use.
Okay. Question number 2 is, can you add threads to your print?
Yeah, you can. I would recommend using heat set inserts if it has to hold any force because they will strip out eventually, especially if you over torque them. Heat set inserts are the way to go.
But that's for composites, right, Joe? Not metal.
Composites. Yes, metal can be tapped. The threads can be printed as well.
And the last question I have here is, how much does the Eiger slicing software cost?
So Eiger is actually free. It comes with your purchase of a printer. Now, there are specific cases where you might have to buy a license, and that's if you do not want to be online. If you don't want any of your parts saved to the cloud or anything like that, you would have to buy a license of offline Eiger.